Nathan Tao. I'm currently assistant professor and also the director of the Mechatronics and Intelligence Robotics lab. So I will give you a quick tour of our lab. So please come in. In this lab, we do robotics research and mechatronics research. You can see in this area, we do most of the sensory and 3D printing research. And on this side, we do the robotics research. So we have two main topics right now. One is for the tactile sensor design. We use the 3D printer and also customize the PCB to design the tactile sensor that will be used on the robotic hand. So that will be on the robot sensor tips.
This is a controller for transport the data from the tactile sensor to the PC for further processing, and the tactile sensor is here. I can show you. Here is a tactile sensor, and it's integrate the heat thermal detection, the heating function, and can detect the normal force power and shear force power. And you can see here it's working under 1 volts per second, 1 volt, and you can see if I touch it, it can detect the normal force and show this is one channel, show on the oscilloscope here. Yeah, and for further research, this may be used for learning-based hand manipulation and other research.
Prototype we just designed, and this will be, you see this is a fingertip shape, although it's a square one, but we will 3D print with silicon to make it a round shape like a human fingertip. It will be a larger size. Take a look at this. So this will be the actual contact surface that will be used for the sensors. So the robot arm tracks the human wrist with a leap motion camera. So if you see there, the leap motion camera is just a small camera like this one, this size, and it can track the 3D position and orientation of the wrist. We map that to the robot arm, so the robot arm can do the same motion like human. And for the hand, we track the human finger positions and also solve the joint angle of the robot hand based on the fingertip position, so it will mimic the motion like that. What we want to do, we want the setup like the human learn to human or human follow human. So you see, when you learn playing table tennis or when you are learning playing badminton from others, you do not mimic the motion, you mimic the effects when you play the game, right? When you play a baseball or something, you just watch how the ball is moving, you watch how the interaction is, right? So that's how humans learn from others, because people are different, right? We have different height, different hand size, different motion, different habitat. So we want, and robot is more different with human, right? So we want the robot to follow the human based on its own unique mechanics, kinematics, dynamics. We are training the AI to understand that.
The robot hand, and this is the camera. The camera will detect the joint angle. Actually, it's the joint position, and I will calculate the joint angle by the Python program. And this angle will mapping to the robot hand. And also my rest, the position or the pose of the rest will mapping to the robot arm, so that I can control the robot to do some movement.
And this big mess right here, here's our prototype. I'm just working on wiring it. This is the underside where all of our sensors are going to be connected. If we can lift it up here, basically these blue sensors here are our 3D printed sensors, and we're basically laying them out, wiring them up, and we're going to basically show a proof of concept of a force sensor array that's been primarily 3D printed. Its current application is it's being designed for automotive industry. So like, for example, like let's say everyone's been on like that 10, 12-hour road trip. You know how it starts to hurt when you're sitting for that long amount of time. Basically, this is the first half is like basically the reason that occurs is that you're applying a lot of force in one area for a really long period of time. And basically, we're trying to detect that, and then second, we're going to develop an actuation system that will basically help distribute that force.